Nosbert. I'm going to present on Bresenham's line algorithm, and I'm going to start by defining the algorithm first. I will look at the characteristics of the algorithm, its application, advantages of the algorithm, then disadvantages of the algorithm. Then I will look at how the algorithm works. Right. Then after that, I will give an example on how to solve Bresenham's line algorithm. Right. The algorithm, it is a line algorithm that is used to draw line. So the algorithm is a line drawing algorithm that determines the points of an n-dimensional raster that should be selected in order to form a close approximation to a straight line between 2 points. So this algorithm, it is an incremental scan conversion algorithm, or it is an incremental error algorithm. It is one of the earliest algorithms developed in the field of computer graphics. Now I'm looking at the application of the algorithm. The algorithm is commonly used to draw line primitives in a bitmap image. Also, the algorithm is used in hardware such as plotters. It is used in graphics chip cards. So this algorithm can be implemented in either firmware or the graphic hardware for modern graphic cards. Now, the advantages of the algorithm is that this algorithm it is purely based on integer calculation. It involves cheaper operations such as addition and subtraction. It is efficient in terms of speed. It involves only integer calculation. Also, it is more accurate. Bresenham algorithm does not perform the rounding operation. Also, it is less expensive as it computes the points on line using addition and subtraction, and it generates the line quickly. The algorithm is easy to implement. Also, the algorithm uses fixed or coordinates only. The disadvantage of the algorithm is that Bresenham's line algorithm method ignores anti-aliasing, and it may not result in a smooth line. Now, we want to look at how the algorithm works. The procedure of Bresenham line drawing algorithm. So, let's start by putting the steps first, then we will explain how the algorithm works. So, let's start the procedure. Right. Step number 1. Step number 1, you input the 2 endpoints of the line. So we say input 2 endpoints. Of the line. For example, x1, y1, and x2, y2. Right, y2. This is our first step. And step number 2. Step 2, you calculate the constants, that is delta x, delta y. Then to compute step 2, you calculate constant, that is delta x and delta y. Right, these are our constants. So, to calculate these constants, for example, delta x is calculated by subtracting x x2 subtracting x1. Delta y is calculated by subtracting y2 minus y1. That's how we calculate the constants delta x and delta y. Right. Step number 3. Step 3. You are now calculating the decision parameter that we use to find or to calculate the next coordinates of a line. So, step 3 would say calculate decision parameter. Right. So, our decision parameter, let's assume pk is the decision parameter. So, how do we calculate the decision parameter? Decision parameter is calculated by subtracting 2 delta y subtract delta x. That's how we calculate the decision parameter. And the decision parameter is used to find the exact point to draw line. That's the use of the decision parameter. Then step number 4. Step number 4, now we are calculating the following coordinates or next coordinates. Let's assume calculate the next coordinates. That is step number 4. Let's assume our current position is xk and yk. So the next points will be x. For x it will be xk plus 1, and y will be yk plus 1. That's how we calculate our next coordinates on the line. But this will depend on the decision parameter. The next points depends on the test cases that we make here on the decision parameter. So, the test cases, let's have our test cases that we will use to define the next or to calculate the next coordinates on x and y.
Right, case 1. If pk value is less than 0, our next pk value, that is decision parameter, pk plus 1, will be calculated by the current pk plus 2 delta y. This is the formula that we use to calculate the current value. And if we calculate the next current value, the next coordinates for y, that is x k plus 1, will be calculated by xk plus 1. And the next coordinates for y, that is yk plus 1, we use the current value of y, which is yk. That is our first test case, case 1. Let's have case 2. Case 2, if pk is greater than 0, the next decision parameter will be calculated by, that is pk plus 1, will be calculated by adding the current decision parameter pk plus 2 delta y minus delta x. So this is the formula that we use to calculate the next decision parameter if the decision parameter is greater than 0. So if we calculate our next decision parameter, we use, let's say we want to calculate the next coordinates for x, that is xk plus 1, will be calculated by adding the current position for x plus 1, which is xk plus 1, and for y, the next coordinates for y, that is the next coordinates, will be calculated by yk plus 1. So, from these formulas, here we are just saying increment x. Here we are saying increment both x and y. So if the decision parameter is less than 0, you use this formula to calculate the next decision parameter, and you increment x only, and you use the current value of y. If the decision parameter is greater than 0, you use this formula to calculate the next decision parameter, and for the next values of x and y, you increment both x and y. That is xk plus 1 and yk plus 1. Right. That is step number 4, where we make the test cases to come up with the test value that we use to calculate the next coordinates. So, step number 5. Right. Step number 5. You will be repeating step 4. Step number 5, you are just repeating step 4. So, let's say repeat step 4 right, repeat step 4, delta x minus 1 times. You repeat step 4, delta x minus 1 times. Or we are just saying, repeat step 4 until end point is reached. Step number 5, you are repeating step 4 until you meet the end point. Now, let's have an example to show how these can be manipulated in a question. You can be asked to draw a line using Bresenham's algorithm. From, let's say, the coordinates. 2, 6, and 2, 6, 2, 7, 10. These are our coordinates, the start coordinates and the end coordinates. So from our procedure, from the algorithm procedure, now we want to show how to calculate this problem using Bresenham's algorithm. So we said from step 1, input the coordinates. So our coordinates, we say 2, 6, and 7, 10. So from this view, it means 2 is our x1, 6 is our y1, and 7 is our x2, and 10 is our y2. So on the graph you plot. Right. That's our step 1. Step 2, we are calculating the constants. That is delta x, delta y, 2 delta x, 2 delta y. Right, so let's calculate. Delta x, we say it is calculated by subtracting x2 minus x1. So our x2 is 7 minus x1 is 2. So 7 subtract 2, you get 5. So our delta x is equals to 5. Right, let's calculate delta y. Delta y, we said from the step 2, it is calculated by subtracting y2 minus y1. So our y2 is 10, subtract y1 is 6. 10 subtract 6, we get 4. Therefore, delta y is equals to 4. Right. Let's have 2 delta x and 2 delta y. Right? 2 delta x is equals to 2 multiplied by 5, our delta x, which is 10. 2 delta y. 2 delta y is equals to 2 multiplied by 4, which is 8. So, therefore here, 2 delta x is equals to 10. Here, 2 delta y is equals to 8. That's our constants. Right? That was step number 2. Step number 3. We are now calculating the decision parameter. And we say, let's assume pk is our decision parameter. Right. So we said decision parameter is calculated by multiplying 2 delta y, then subtract delta x. 2 delta y, subtract delta x. 2 delta y is equals to 8. Right? Then delta x is equals to 5. So our decision parameter is equals to 3. Right. So we want to calculate the next value of x and the next value of y. So from Step number 4, we said we test the precision parameter using the test cases, that is case 1 and case 2. So in this case, our decision parameter is greater than 0. Our decision parameter is 3, therefore it is greater than 0. So we are using case number 2 to calculate the next point for x and y. We are using case number 2 to calculate our next values. So let us calculate the next values for y. So we say our next decision parameter, let's have a table here where we update our values. Right, this is yk plus 1. This is xk plus 1. This is the decision parameter, and this is the step or the point k. So we said at k naught, we have p k naught, which is equal to 3. Right. And our current value for x, that is xk, is equals to 2 here. Yk is equals to 6. Right. So we are now calculating the next value for x and the next value for k, and we are using case 2. So we say our next pk is equals to pk plus 2 delta y minus 2 delta x. Right. Let's update here. Alright, so our decision parameter is 3 plus 2 delta y. 2 delta y is equals to 8 plus 2 delta x is equals to 10. So let's subtract here. 3 plus 8, we get 11, subtract 10, 1. Therefore, the next decision parameter is equals to 1. Right. The next decision parameter is equals to 1. So here, our decision parameter was positive. So here we are supposed to update x and y. We increase. Our value for x was 2, then plus 1, we get 3. Our y here was 6, we update plus 1, 7. So we calculate the next decision parameter and we get pk1 is equals to 1, which is again positive. So we are using case 2 again to update the next value for x and the next value for y. That is, we are adding 3, that is our current value for x. 3 plus 1, we get 4. 7 plus 1, we get 8. Right. So we use case 2. Right. Let us now calculate our next decision parameter, which is pk2. Right. pk2, our current pk was positive, so we are using case 2 to calculate the next decision parameter. pk plus 1 is equals to, we use case 2, pk plus 2 delta y minus 2 delta x. Right, our current decision parameter is 1 plus 2 delta y is 8 plus 2 delta x is 10. So 8 plus 1 minus 10, we get minus 1. Therefore, our next decision parameter is equals to negative 1. It is less than 0, so we are going to use case 2 to update our next place value. We are using case 1 to update our next place value. Our decision parameter is negative 1. So we say if it is negative 1, this is less than 0, we update x, which means we increment x only. So we are incrementing x 5, and we use the current value for y, which is x. And the formula that we use to calculate the next decision parameter, we use the formula on case 1, which is pk plus 1, our next decision parameter. We use formula from case 1, pk plus 2 delta y. And our current decision parameter is minus 1 plus 2 delta y is equal to 8. Minus 1 plus 8, we get 7. Therefore, our next decision parameter is equal to 7, which is K3, PK3 is equal to 7, which is greater than 0. So we use case 2 to update the values or the next coordinates for x and y. So here we have 5, we update 5 plus 1, 6, 8 plus 1 is 9. So we use case 2 here to calculate the next decision parameter. So we said it is positive, so we are using from the formula from case 2, pk plus 1 is equals to pk plus 2 delta y minus 2 delta x. pk is equals to 7 plus 2 delta y is equals to 8 minus 2 delta x is equals to 10. 7 plus 8 is equals to 15. 15 subtract 10, we get 5. Therefore, the next pk value is equals to 5. It is positive. So, again, we are using formula from case 2. We use case 2. This is our K4. Pk4 is equals to 5 positive. So if it is greater than 0, we are incrementing both x and y. We are incrementing x plus 1, which is 7, and y plus 1, which is 10. Then this is our end point. Because we are told to calculate or to draw a line from 2, 6 to 7, 10, from 2, 6 to 7, 10. So our steps end here. Then to plot a graph, let's have a graph here. This is our x, this is our y. Right? We have 1, 2, 3, 4, 5, 6 columns. This is our 2, our 3, our 4, 5, 6, 7, our endpoint. For y, our 6, 7, 8, 9, 10. So we are now plotting the graph using the coordinates that we calculate using the. We started from this pixel. The first coordinates are plotted on this pixel, and our next coordinates is y is 3, x is 3, and y is 7, which is this pixel. Then our next coordinates, x will be 4 here, and y will be 8. We refer to this pixel, right? Next coordinates, our x is 5, and our y is again 8. We are referring to this pixel, right? Next coordinates, our x is 6 and our y is 9. We are referring to this pixel. Then the last coordinates is 7 and 10 here. So the Bresenham algorithm always selects points that are approximate close to a straight line. Then it is used to draw line. I thank you.